In this video, I'm going to show you how to count how many GPU cycles your shaders are taking in Unity. This is a very important topic nowadays because we have an ever-growing list of devices with higher and higher resolutions. The more pixels your devices have, the more fragment shaders you have to run, and therefore it becomes very important to have your fragment shaders super optimized. Otherwise, your game won't be able to render at 60 FPS and you will just upset your players. I am Ruben from the Gamedev Guru, and this is my first video on YouTube, so it is gonna suck. But nevertheless, I have very good information for you, and I just don't want to keep it for myself, so here we go. What we are going to do in this video is to analyze the GPU cost of your shaders. This is important because the fragment shaders are one of the most expensive parts of the GPU pipeline. So chances are very high that your fragment shaders are slowing down your game right now. So I'm going to show you one workflow that will allow you to see how much time in GPU cycles you are spending with each of your shaders. We will do so by using one free tool called Mali Offline Shader Compiler, and it's going to be super easy to do, so don't worry about it. In fact, I'm going to show you all the steps that you have to follow in order to get the numbers that you're wishing. If you open your favorite browser and look for Mali Offline Compiler, then you will likely land on this page. And you will see that the Mali Shader Offline Compiler is part of something bigger called ARM Mobile Studio, so we will need to download this thing. For that, go to Downloads, and of course don't forget to reject the cookies if you can. Good luck with that. And here on the right side you will see that there are three packages. We have Windows, Mac and Linux. In my case, I'm using Windows, so this is the package that I will need to download. So, just download it and install it. It is as easy as that. Now back to Unity and the sample project here. What I'm going to do is to show how I measure the cost of the shaders applied to this great looking knight. For that, I just need to click on the knight and find the material that we're currently using. In my case, it is called Guard 1. And here in the skin mesh renderer, we can see that we reference two materials. So I'm just going to go for one of those. As we can see, we are using the standard shader. Pretty standard nowadays, So what I need to do is to click on Edit, and this will redirect me to the inspector window, and it's going to inspect the settings of this shader itself. As you can see, there are a lot of properties here on the shader, but we are not much interested in that. What we need to do is to click this section that says Compile and Show My Code. So you just click here. After Unity is done compiling the shader, it will open for you the compiled shader. And as you can see, in the case of the standard shader, it's going to be huge because we have a lot of standard shader variations or variants. One of the reasons that this standard shader is so big is because we have so many variants. And this happens because standard shader has a lot of different parameters and texture channels and everything like that, which is going to cause that we have many different possibilities for this shader. So what we are going to do here is to look for two specific shaders or sub-shaders. We're going to look for the vertex shader and for the fragment shader because we're going to compile them separately and analyze them as well separately. The easiest way to do this is to look for ifdef, like I'm doing here. And if you look for the ifdef macro, you will see that it immediately goes to the vertex shader. We can take advantage of this, and what we need to do here is to copy what is inside this ifdef vertex. So I'm going to scroll down, and as you can see, this is the main program. And I'm going to stop scrolling down here just before the end if. When we are here, we're just going to copy that into the clipboard, and we are going to pass this in another specific file. In my case, I'm going to use Visual Studio Code, so I just need to paste the contents of the clipboard, so we only have the vertex shader inside this file. Important thing to notice is that this file has to end in vert extension, so that Mali Offline Compiler can actually understand this is all about a vertex shader. And then what you need to do is to open the command line and to navigate to the place where you actually have this file saved in. In my case, it is just temporal. And you need to invoke the Mali Offline Compiler by writing Mali OC, and then the name of the shader, which will be shader.vert. And doing this is just going to be enough to display the performance metrics you were looking for. As you can see, this vertex shader has about 2.2 cycles spent in arithmetic operations, which is okay. But then it also has a lot of load and store operations. As you can see, 22 is way too high. And what Mali is actually saying to us is that this shader is bound by load and stores. So if we wanted to optimize this shader, we will need to reduce this number. We can also do this for the fragment shader. So all we need to do is to look for the fragment section. So we looked for the vertex before, and if we search again for this macro, we'll find that we also have around here the fragment shader like we see in the screen right now. So we need to do the same. We just copy all the code until we end the fragment shader. And this is usually finished with the last end if. Let me scroll down, and this is the place we were looking for. So Control-C or Command-C if you are on Mac, of course. And then let's put this into Visual Code. So here is where the place I can paste it. And again, we open the command line, we go to the specific place, and we again invoke the Mali offline compiler with the new shader name. In this case, is the fragment shader. Don't forget it has to end with the fragment extension .frag. So again, we compile it and we see very juicy results again. In this case, we see that the shortest path is about 4.8 cycles of arithmetic operations, and this is different than the longest path. So this normally it means that we have some conditionals going on. In any case, we are always bound by arithmetic operations because the variant and the texture fetches are not so bad, as you can see here. If you wanted to optimize this specific fragment shader, then what you need to do is to focus on the bound section. So if your shader is bound by arithmetic operations, then you need to optimize this section. Just to show you a very short demonstration, I could just go to a big if block like this one and destroy it. Then I can save it, and then I can rerun this Mali profiling tool. And then we will see that we dropped from 7.9 to 7.1. And of course, I just destroyed a part of code. This is not the same as optimizing, but just for you to know that this is also something you can do to quickly iterate over your shaders. Just make the changes and then compare the performance metrics that you get before and after. With this, I conclude this very short video, and I hope this was helpful for you. Now, don't forget that this method has a few limitations, of course. The first limitation you have to be aware of is that this tool is mostly done for Mali devices, and it always depends on which architecture, even within Mali, you are targeting. And surely Mali is not the biggest name in the market of GPUs right now. It is big, but it's just not the biggest. So just be aware that these numbers are going to be applicable only for Mali. Still, this is going to be very useful in general because it will show you all the optimizations that you can get done, right? The before and after, and this will help you in mostly every single platform. So if you use this in relative terms, you're going to be just fine. The second limitation is that even if you're just targeting Mali architectures, these numbers can change between different driver versions. So take this again with a grain of salt. Finally, the last thing I wanted to mention is that this is all static analysis. This is only approximations. So this is ignoring most of the things that really happens in this GPU. For example, all the cache mechanisms are ignored here. What this means is that you will get in real life different timings, mostly because it is not the same to run a shader the first time or the second or the third, because some data was not available in cache and some data might be available in cache later on, which is going to alter all the timings that you get. Still, this is going to be a very useful tool to have in your tool shelf, mostly because at some point during your game development, you're going to be fragment bound. And this tool is going to be able to answer you, should I use standard shader or should I use an unlit shader or a diffuse shader? Having numbers is the best thing you can start with because this is going to make everything easier. Okay, my friends, this was the end of this video. Don't forget to download your Unity performance checklist if you want to take your game to the next level. Take care. See you.